Hello everyone, welcome back again to Plaxis 3D Shallow Foundation course from theory to practice. This is lesson 51, and in this tutorial we are going to simulate a shallow foundation on soft clay reinforced with geogrid-encased stone columns using Plaxis 3D. If you remember, in previous example we did almost the same thing. We did a simulation of shallow foundation on soft clay reinforced with stone columns, but in this example instead of just stone columns we will use a geogrid-encased stone columns. As you can see in this figure, if you have stone columns like this, which is composed of crushed stones and gravels, when we apply the foundation rested on these columns, we can see the buckling happens near the ground surface, and the distance of this buckling effect is about 2.5 to 3 diameters of the stone columns. So in practice, engineers use encased stone columns, and generally geosynthetic material are used for these purposes. So in this example we will try to simulate this situation in Plaxis 3D. So it means when we use geosynthetic material as a case for stone columns, it provides a lateral support against the buckling when we apply the foundation. So think like this: we have a stone column and geogrids or geosynthetic material, and when we use a geosynthetic material as a case for stone columns, it becomes like a composite material, like two materials. It's called geosynthetic encased stone column. So I will open the Plaxis 3D from previous example. So because we did in the previous example, but the only thing we will define a geogrid as an encasement for the stone columns. So I will open lesson 50 from previous example, and I will save this Plaxis file under a different name, under this name. So I will copy this title, and this example was from lesson 50. Okay, I will click on file and save project as, and I will copy this title and paste in here in lesson 51. Okay, so right now this is lesson 51, and we have to use a geosynthetic for the stone columns. So let me temporarily hide this soil volume. I don't know why the color of this interface is below. So maybe I click on here, we can see this is an interface. Okay, I think this is a mistake from previous example. Maybe we can solve it in here. We can, as we can see, we can just click on here and change the material mode for the interface from custom to from adjacent soil, and actually it was a mistake from previous example, and it will not affect the results. You can run the analysis for previous example again. Okay, so the only thing we change in this example, we go to structures. I think it is okay. Now we can start the calculation. So I click on calculate, and we will wait until the calculation is finished. Okay friends, after a long time the calculation is finished and we can start viewing the results now. I save the project again and I click on view calculation results. We can see now what is the effect of Geogrid-Encased stone columns on the settlement of shallow foundation. So we can see in previous example the maximum displacement was about 9 centimeters. So in this example it is about 6.5 centimeters. So we see it affected the settlement, and we have a more improvement right now due to the reinforcing the stone columns with geogrids. If we select the unreinforced soil, we can see the maximum settlement is about 22 centimeters, and for encased stone column reinforced soil we can see it is about 6 centimeters. And from this example we can see how the soil improvement using stone columns improve the settlement of the foundation. So we can click on total displacement, and we can see in here, in case for unreinforced soil, we can see the displacement contours is like this one, and for Geogrid-Encased stone columns reinforced soil we can see it is like this one. We can also check the load displacement curve for both cases. So we choose the M stage in X direction and the displacement in Z direction in Y axis. We click OK. So we can see this curve is a load displacement curve for unreinforced soil. We can do like previous example. Maybe I can write unreinforced soil in here. Also I will just leave this construction phase. After that I will add the load displacement curve for the Geogrid-Encased stone column reinforced soil. Also I will change the name reinforced. Also I will deactivate these two stages. We can see how the settlement of the foundation is decreased and the stiffness of the soil is increased when we use the Geogrids-Encased stone columns for reinforcing the soft clay. Okay friends, this was for this example. I hope it was clear. In the next lesson we will try to simulate the another technique for soil reinforcement in Plaxis, which is jet grouting. Okay, see you in the next lesson.